Let me start with a situation you might have experienced. You've had a long conversation with ChatGPT about your summer vacation. After discussing various destinations, flight options, and hotels, you suddenly remembered something about the first place you talked about. So you asked, "What was the first destination we discussed?" ChatGPT responds with the most recently mentioned destination, not the one from the beginning of the conversation. This represents a common limitation of today's intelligent assistants, or IAs. While they can engage in natural conversation and help you with various tasks, they struggle to remember earlier parts of the dialogue. Our work focuses on addressing the challenge of long-term recall in LLM-powered IAs. Through a formative study with 30 participants, we found that this isn't just an occasional inconvenience, but a fundamental barrier to natural conversation with IAs. Let me show you another scenario that illustrates this problem more clearly. Try activating the built-in IA on your smartphone.
Tell me about Hawaii.
Hawaii is an island state in the western United States.
How many islands does it consist of?
Search results for how many islands does it consist of?
No. How many islands make up Hawaii?
This demonstrates the current problems faced by IAs. First, they fail to maintain conversational context. They don't understand that it refers to Hawaii. Second, they can't utilize information from previous exchanges. These limitations force users to repeatedly input the same information. The root cause of these issues lies in the input length and previous context processing limitations of the language models powering IAs. While large language models can handle longer contexts, this still doesn't constitute true long-term memory. So we propose a prompt chaining framework for IAs that applies memory augmentation techniques to LLMs. Our approach divides the user-IA interaction process as follows. The context extraction stage generates semantic representations of user inputs. It uses attention mechanisms to extract key information. The memory module stores extracted information in both short and long-term memory. Short-term memory stores the most recent K conversation turns as a buffer. Long-term memory efficiently stores and retrieves key information from previous conversations using a vector database. The memory module also retrieves context-relevant information through dense passage retriever methods. The prompt generator constructs multi-step reasoning chains based on stored information. It dynamically adjusts the number of reasoning steps between 3 to 5 based on query complexity. The response generator produces responses through the LLM interface. It creates consistent and personalized responses using all context information collected from previous stages. Let's revisit our earlier scenario with our framework.
Tell me about Hawaii.
Hawaii is an island state in the western United States.
How many islands does it consist of?
Hawaii consists of 137 volcanic islands, including 8 main islands.
Our system understands that it refers to Hawaii, successfully maintains conversational context, and provides accurate information. How about long-term recall? On 3 widely used benchmarks in conversational systems, LLMs operating within our framework showed consistent performance improvements compared to those without it. The user experience is also noteworthy. We tested with 47 participants in everyday conversation scenarios. We asked users to compare GPT 3.5 with and without our framework in terms of sensibleness, consistency, personalization, and overall satisfaction. The results showed improvements across all metrics. We've just introduced our prompt chaining framework for improving long-term recall in LLM-powered IAs. Thank you for watching.